Good morning, Year 8. So, in the last lesson I left you with this little puzzle. See if you got them right. So, these are the first letters of the numbers. So, this is 1, 2, 3, 4, 5. So, the next letter here would be S for 6. So, that's that one. Shall I put that in red? If I can do that, there we go. Alright, so we've got S. This one we have Monday, Tuesday, Wednesday, Thursday, Friday days of the week. So again, the next one would be S for Saturday. Okay, and then these are the colours of the rainbow. So you've got red, orange, yellow, green, blue, and the last one would be V for, no, sorry, red, orange, yellow, green, blue, I for indigo, sorry. So we'll just change that to an I. Whoops. So there we go. Okay. Hope you had a bit of fun with those. So today's lesson, we are looking at arithmetic or linear sequences. There are two different names for these. Arithmetic or linear sequences, they're sometimes called. So we're going to start by understanding the properties of an arithmetic sequence, and then we're going to look at finding the nth term of an arithmetic sequence. Now, for your 20 questions, a lot of the time you are being asked to find nth terms. So for some of you, this will just be a bit of revision and practice. For some of you who have struggled with that on the 20 questions, hopefully this will be a little bit more practice. And you'll be able to pick these up on the 20 questions. But for our starter, we'll just have practice of what we did last lesson. So we've got 4 terms for sequence, 5, 8, 11, 14. Can you write down the next term in the number sequence, the 10th term, and then it says if the 100th term is 302, what would the 101st term be, and what would the 99th term be? So press pause, okay, and then press play when you're ready for the answers. Okay, so what we need to spot first is that we are going up in threes. Okay, so the next term would be 3 above 14, which is 17. Okay, it's plus 3. Okay, so to find the 10th term, you can't just double the 17, that won't work. You just need to keep adding threes. So it would be 32. Okay. All right. So we're going up in threes. All right. And then get to the 10th one, it will be 32. So it says here that the 100th term is 302. So what would the 101st term be? Well, that would be the next one along. And we know we're going up in threes. So it would be a 302 plus 3. So it would be 305. And the 99th term would be 3 before this one. So we need to take 3 off 302, which is 299. Okay. There we go. So we're going to be, first of all, looking at the properties of an arithmetic sequence. So arithmetic sequences, or linear sequences as they're known, have what we call a constant difference. So this means that we are always going up, either adding the same amount or subtracting the same amount. These are not multiplication ones, okay? So arithmetic sequences, you must always be adding the same amount each time or subtracting the same amount each time. So if you remember, the word difference is looking at the gap between numbers. So we're basically saying the gap between each number in the sequence is the same. Okay? So that's arithmetic sequences. So what I would suggest is you pause and just get those examples in and that sentence into your notes, so you know that. In GCSE exams, you are given a set of sequences and asked to name them. Okay? So we're going to look at several different sequences and you will be asked to identify which ones are arithmetic, which ones are geometric, which ones are Fibonacci, and we're going to look at all of those, but you need to be able to identify them, so just get those in your notes ready. So then we're going to look at the nth term. So the nth term is a formula or a rule that helps us to find any term in the sequence. Okay, so on the first starter question you had to find the 10th term, and the only way you could do that at the moment was to keep adding 3. But if I asked you to work out the 1000th term, it would take you a long time if you just had to keep adding 3. So we're looking for a quick way that says, here's the rule, the 1000th term, put 1000 in, and the answer would be this. Okay, so we're looking for that nth term. So we're going to start with the simplest sequences. Okay, so what you need to do is you need to copy this table into your books. Okay, so you will need 1, 2, 3, 4, 5, 6 rows and 4 columns. So what I suggest you do is just pause and get that table in your books and labelled up. Okay, so when you've got that sequence in your books, the first sequence we're looking at are multiples of 2. So another name for that is the 2 times table. Okay, so how do we work out the 2 times table? Well, we would start by doing 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. Okay, so we're always doing 2 times something. So if I'm looking for what's known as the nth term, okay, the first term is 2 times 1, the second term is 2 times 2, the third term is 3 times 3, the nth term would be 2 times n, okay, which we write as 2n. So the general term, okay, for multiples of 2 is 2n. So we would look at that, so the sequence would look like this, and it is just the 2 times table: 2, 4, 6, 8, 10, 12, 14. Okay, now the common difference, what are these going up in? Well, they're going up in 2s. The 2 times table goes up in 2, so it's plus 2. So all the times tables are arithmetic sequences. Okay, so I've done the first one for you. What I'd like you to do is pause and have a go. See if you can do the multiples of 3. What would the general term be? What would the sequence look like? What would the common difference look like? And fill that in. And then the last one, we've got multiples of negative 3. Okay, so think very carefully about that one. So pause and see if you can fill that table in. Okay, so hopefully you've pressed play and you've got your answers filled in to check. So multiples of 3 would look like this. Get that to move. And the sequence is 3, 6, 9, 12, 15, 18, 21, and so on. And then the common difference, well, it's going up in 3s. Multiples of 4 would be 4m. We'd have the 4 times table written out, and the common difference would be plus 4. And similarly for multiples of 5 is 5n, 5 times table, and the common difference is plus 5. So then we've got multiples of negative 3. Okay, so let's see what that looks like as a sequence to start with. That's going to be negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21. Okay, so that's minus 3 times 1, minus 3 times 2, minus 3 times 3. So it's going to be minus 3 times n, and you must have that minus in the front. And the common difference is, well, instead of going up, these are coming down. So the common difference is minus 3. So check your table. Correct anything that you didn't get right with a different colour pen, just so you know what's correct. Okay. Okay, so we're going to look at some slightly harder examples now. Okay, we looked at the basic ones. Our first example is we're going to find the nth term of this sequence here: 5, 7, 9, 11, 13. So what I've done on the top, so when you copy this out, you want to write it out, but you want to leave some space above it. So the first thing I've written down is the position of each term. So this is the first term, the second term, the third term, fourth term, fifth term. We're looking for the nth term, so the answer will come out here. So with any of these questions, the first thing we always do is we look for the common difference. Okay, these are all arithmetic sequences. So it's 5 plus 2 gets me 7, 7 plus 2 gets me to 9, 9 plus 2 gets me to 11, and 11 plus 2 gets me to 13. So the common difference is plus 2. If we look back at our table, okay, when the common difference was plus 2, that was the 2 times table. So we're going to write out the 2 times table here. 2, 4, 6, 8, 10. 5 times 2 is 10, 4 times 2 is 8, and so on. So then the nth term for the 2 times table, if you remember from your table, is n times 2, which is 2n. So the first part of my formula is 2n, okay? But this isn't the same as the 2 times table, okay? It's got the same difference, but it's not the same set of numbers. There's a little bit more work to do. What I need to do now is work out how did I get from this times table to the sequence that we're listed with, okay? So how do I get from 2 to 5? Well, it's plus 3. How do I get from 4 to 7? Plus 3. How do I get from 6 to 9? Plus 3, plus 3, plus 3. So the same has to be done here, plus 3. So the final sequence, the final nth term for this sequence will be 2n plus 3. That is the nth term for this sequence. Okay, so we're going to look at another example. So again, I've got the position numbers written up. Okay, so this is the first number in the sequence, the second number, the third number, the fourth number, the fifth number. We're looking for the nth number, i.e. the nth term. So as before, we would start by looking at the common difference, which is plus 4, and so on. Okay, so they're all plus 4. Okay, so thinking back to that table, it's the 4 times table that goes up in 4s or has a common difference of plus 4. So I'm going to write the 4 times table out and change my colour. So we've got 4, 8, 12, 4 4s are 16, 5 4s are 20. Okay, and then n times 4 is 4n, or you can look at the general term for the 4 times table is 4n. Okay, so as we did before, we need to look at how did I get from the 4 times table to this sequence here. Okay, and then we can work out what the nth term is for this sequence. So 4 to 1, you would have to subtract 3. 8 to 5, you would have to subtract 3, and so on. So they're all going to be 16 to 13, subtract 3, 20 to 17, subtract 3. So therefore, I'm going to need to subtract 3 from 4n. So the nth term is exactly what we've got written here. It's 4n subtract 3. Okay? Okay, so here's some questions for you to have a go at. Just remember, when you copy the sequence out, you need to leave some space above because you're going to need to write the times table in, as well as working out how to get from that times table to your sequence. I'll put the answers up in a minute. All of these, I'm just having a quick look, should be positive, so add something, and we'll look at how to do the subtraction ones in the next lesson. Okay, so if you've got all of those, the answers are below, so yeah, get a purple pen or something and check your answers. Okay. If you're not sure about one or why that's the correct answer, you can just check it. So for example, if I look at H and I look at the fourth one here, okay, I would put 4 in here, 3 4s are 12, 12 add 17 is 29, so I know it works. Okay, so next lesson we'll look at arithmetic sequences that are going down, so we get that negative times table. Okay, and then we'll also look at how we substitute in. Okay, have a good rest of the week.